مقتطفات من المحاضرة التي غيرت فهم الطاقة المظلمة. أول إعلان ومحاضرة عن نتائج ديزي حول الطاقة المظلمة الديناميكية في اجتماع الجمعية الفيزيائية الأمريكية في 4 أبريل 2024 ساكرامنتو، كاليفورنيا. قدمها الأستاذ مصطفى إسحاق نيابة عن تعاون ديزي بالكامل.
Good morning, everyone. I'm Natalie Pauling-Delabrouille from LBL, and I have the pleasure to be introducing this session dedicated to the Dark Energy Spectroscopic Instrument, or DESI. DESI is presenting today its first year results, and that's really the focus of this invited session. I first want to thank our sponsors, in particular DOE, who is funding the project, and the 72 participating institutions to this collaboration. Speaker will be Mustapha Ishaq from the University of Texas, Dallas, who will present the cosmological inference of this whole sample of quasars, galaxies, and Lyman alpha forest across all redshift ranges.
Hello, everyone. My name is Mustapha Ishaq from the University of Texas at Dallas. And I'm very delighted to present to you today the results from the first year of DESI, the cosmology results, and that is on behalf of the entire DESI collaboration. What is DESI telling us about the universe, about the cosmological parameters? First, let's recall that DESI is an experiment that was designed and built with the chief goal to constrain the nature of dark energy that is causing the acceleration of the expansion of the universe. When it is put into the Friedmann equations, it does cause the expansion of the universe to accelerate. So mathematically, the acceleration of the universe is not a problem. However, what we don't know is the physical nature of dark energy. When we take DESI data and we combine it with the CMB, we observe a trend. We obtain a 2.6 sigma discordance with the value of the cosmological constant. So you see this orange plot here, this orange contour, and you see it. You see that the point of a cosmological constant here is not inside the ellipses. So this is an interesting trend, seeing what the data is telling us. And we combine it with the supernova data one at a time. So you see that again, if we combine DESI with Union 3 here in orange, or we combine DESI with DES 5 supernova here in blue, we see that those two combinations also are away from the vertical line here, -1, and the horizontal line of 0. They are away from it. In fact, we see this trend of the data, the contours. We take a big breath to hit the button and to see, in fact, what the universe is going to tell us. And the universe did not disappoint. We see that we obtain, when we combine the data, the DESI BAO plus the CMB plus Pantheon plus, or DESI BAO plus CMB plus Union 3, or DESI BAO plus CMB plus DES 5 supernovae, when we combine these, each combination has moved away from the -1, 0 value of a cosmological constant. What is the significance of this result? And we did that. We looked at the significance of this result, and what we found is 2.5 sigma, and for the second is 3.5 sigma, and then for the third is 3.9 sigma. And don't forget, DESI plus the CMB gives us a 2.6 sigma. And another logical thing to do is to look into a Bayesian model selection analysis to see, and we did that as well. The results are consistent with the picture above that you see about the departure from the -1, 0. And now we can reflect a little bit on this result. When you look at this result, so are we seeing first hints of a time-varying equation of state of dark energy in some tension with the cosmological constant of a lambda CDM? But again, we need to be prudent with these first results, and we are digging farther into them with further data from DESI. However, if this persists and this grows in its significance, this is an interesting result. This is very interesting result. And in fact, for some people who have been working for 2 decades on the cosmic acceleration and so forth, the question that comes to mind is, but again, we have to be prudent. Is nature, is the universe giving us a break about the cosmic acceleration problem? But again, we have to be prudent and wait and see how this persists, how this grows, and look at it. the heart of our results. When we go to the dark energy, if we consider a model with a constant equation of state, we assume that, we want it to be that way, then the result that comes out of it is consistent with -1 of a cosmological constant. However, when we give the freedom for the equation of state as it should to vary in time, then we find that DESI data, DESI BAO, plus the CMB already gives a 2.6 sigma discordant with the cosmological constant. And if we combine DESI with one of the supernova sets like Union 3 or the DES year 5 supernovae, that also gives some preference, some trend to this quadrant. How about maybe we coin it today the preferred quadrant of dark energy? We move on then next to do the following things, is to consider DESI plus the CMB plus one supernova set at a time in this order. So Pantheon plus Union 3 DES year 5 supernovae. If we do that, then the preference for this quadrant is increased, and some hints of a departure of the -1 0 value of a cosmological constant, those hints indicate some tension at the level of 2.5 sigma or 3.5 sigma or 3.9 sigma with the cosmological constant. So again, I would like to say, this is very interesting result, but we need to look at it prudently, and we are digging more into it using more data from DESI. But if this persists, and this grows in significance, this is a very interesting result. And maybe we are looking at some break on the cosmic acceleration problem. This is what DESI is telling us today about dark energy. Thank you all for your attention.